This video is going to go over the second review quiz from chapters 8 and 9. The answers will also be posted. I'll go through this pretty quickly, mostly because I only have about 10 minutes before second period starts. Okay, number 1, given a triangle, you're given angle A, you're given angle B, you're given side A. If you label what you know, you're given angle A, you're given angle B, you're given this side. Well, that means you also know angle C. So you actually know angle, 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 side, and we're asked to find side C, and that's just a straight up law of sines problem, and we don't need to worry about the ambiguous case because we actually know that the angle of C is 80 degrees, and so we just straight up do law of sines right here to get our answer of 17.42. It says round to the nearest hundredth, so that's what I did. Okay, number 2. In this triangle, we're given an angle, and we're given two sides. We're actually given side, angle, side. And we're asked to find the angle across the side across the angle. We know, well, that's a straight-up law of cosines situation. And I just plug and chug into the law of cosines, and I get 8.19. Number 3 gives us three sides of a triangle. It says find the largest angle of the triangle. Well, I know the largest angle of the triangle is across from the longest side, so that's got to be across from the 15. And I'm going to use law of cosines to find that angle. 15 squared equals 8 squared plus 10 squared is minus 2 times 8 times 10 times the cosine of A. I'm going to do some algebra to solve for the cosine of A, and actually that's a negative there. And then I do inverse cosine to find the angle, which it says round to the nearest degree, so I'm rounding to 112 degrees. Number 4, it says find the area of a triangle. And if you look at what we're given an angle, and we're given the two sides surrounding it, and there's an area formula. It's the only one that I really remember because we can use law of sines, law of cosines to get whatever we want if we have a unique triangle. And the formula is that it's 1/2 side times the sine of the angle between them. So I just put that into the calculator and get this answer, and it says round to the nearest thousandth, so that's what I did. Number 5, this is about the ambiguous case for the law of sines. So I drew a picture of what we have. We're given that angle A is 47 degrees. We're given that B is 8. And we're looking at what side A could be so that there are different triangles that could be determined. So remember that the key length here is when this is a right triangle. That would give us one triangle. If we're shorter than that, then this side won't reach and we can't get a triangle. If we're longer than that, for instance here, I could swing this side with the same length around and get a different triangle. That's where we have two triangles. But if we get long enough, in fact longer than side 8, this side, we can't really swing it around to get another triangle, and thus what we're looking at is between the right triangle length and the length of this side. Okay, this will be a right triangle when this side is equal to 8 times the sine of 47 degrees, and that's about 5.85. And so my final answer is that A is between 5.85 and 8. And notice that that does not include either one of those values, because if it were 5.585 exactly, there would be one triangle. If it were 8 exactly, there would be one triangle. All right, number 6, simple problem. Gives a plane. It's at 31,000 feet. Okay, I'm just going to write that as 31. And it says that an airfield is 150,000 feet along the ground from this, and it says the plane is to descend along a straight line path. Find the angle of descent. The key is having this angle in the right place. Okay, the angle of descent would be this angle, so it's the green one, not the yellow one. Okay, and so I noticed that the angle of descent is same as the angle of elevation here, and then I'm just going to use inverse tangent to find that angle. You know the tangent of the angle is 31 over 150, so use inverse tangent to find the angle to the nearest hundredth, and you get this answer. All right, number 7. The Riddler is on top of a bank. Okay, so here the Riddler's up here, and Batman's down on the ground, I suppose, and he measures that the angle of elevation is 53 degrees. And then Robin is further away, and his angle is actually smaller. It's 47 degrees. I can also find this angle as 127 because I know these two equal 180. We're asked to find the height of the bank. So there's different options here. The option that I took was I'm going to use law of sines to find this angle. Okay, so I know this angle up here is 6 degrees because I know this is 127, this is 47. In order those to add up to 180, this has to be 6. So I just said 100 over sine of 6 degrees is equal to x over sine of 47, and I solved for x. Okay, and I stored that in the calculator. I left it as the answer, and then in order to find this height, I know this angle. That's the opposite side. Ooh, I think I messed up. I did mess up. So I know this angle is 53 degrees. I know the opposite side. This is x. I'm trying to find the height. I need to use sine. Right here I wrote inverse tangent, which is wrong. So it's the sine of 53 degrees equals h over 699.669. Whatever. When we get a calculator, I'll just do it. All right, I put that in the calculator, and I got 558.78 feet. The answer on the key is wrong because I used tangent. I should have realized that that answer made no sense, because how could this leg of the right triangle be bigger than the hypotenuse? That's impossible. So here it's done correctly, about 558.78 feet. Pretty tall building. All right, moving on to the back. You can pause this and slow it down if I'm going too fast. I'm asked to solve this trig equation. I should recognize this is a quadratic that's already set equal to 0, so I'm factoring. I think this is factored correctly. Then I can use the zero product property to get 2 equations. All right, the first one, sine of theta is equal to negative 3/2. I should recognize that that's impossible. The second one, now I'm just going to say, where is the sine equal to negative 1/2? And I just know my unit circle really well. That's got to be here. That's got to be here. So we're talking about, and this is in degrees. And I think I messed this one up. This is not 150 degrees. This is 210 degrees and 330 degrees. All right, moving on to number 9. Another equation to solve. You could say, well, I could divide both sides by cosine. The problem is you might lose solutions about where cosine is equal to 0. So instead of doing that, let's factor. Okay, it's already set equal to 0. This is sort of usually the best strategy to do here. So let's factor. I can factor a cosine of x out of each term. I end up with this. Use the zero product property. I get 2 equations. Cosine of x is equal to 0. I just know the unit circle. That's when x is pi over 2, or 3 pi over 2. And I also get sine of x is equal to negative 1. Well, that's 3 pi over 2. So this answer actually sort of repeats. So the answer is just pi over 2 and 3 pi over 2. All right, last one. You're given this equation to graph. There's lots of properties about it. A very important one is the period is pi. It's 2 pi over 2. Okay, so when I made my scale down here, I made it by pi over 4s, because that's a quarter of pi. The axis of wave is at 1, y equals 1, so I put that in there as the middle line, and I know I'm going to go up 3 from there and down 3 from there. So I'm going to go up to 4, and I'm going to go down to negative 2. Then I needed a starting point for the function. Well, sine starts in the middle, but this one is shifted. This thing says shift the graph to the right pi over 4. So instead of the thing starting here, I'm starting it here. Okay, and then it's real simple. Okay? A quarter of the period later, which I've got my scale set up by, we're at the top, and we're at the middle, and we're at the bottom, and we're at the top, then we're at the middle, then we're at the bottom, then we're at the bottom, the middle, blah, blah, blah. Okay, so it just goes like that. It's real easy if you get the scale set by quarters of periods.